Hello, welcome to another video. This is bond pricing and interest rate determination number 6. So here I have my yield curve spreadsheet, and I just wanted to show this to you. And notice that this analysis assumes that the pure expectations theory of interest rate determination is correct and complete. Okay, and now you know in the real world it's not. It's correct but not complete. In other words, forward rates reflect the desire of investors to have liquidity and to avoid illiquidity. But more on that in a few moments. So here we go. Here are, excuse me, dates 1, 2, 3, 4, and 5. Let me restate that. Here are 1, 2, 3, 4, and 5 period maturity treasury strips. And S sub 1 is the 1 period spot rate, S sub 2, 2 period spot rate, S sub 3, 3 period, and so on. And here I have the zero coupon yield curve at date 0. 7, 8, 9, 10, and 11% per period assumed. And in these cells, we're calculating the forward rate. So this is the forward rate over the second period, the forward rate over the third period, forward rate over the fourth period, and forward rate over the fifth period. Okay? You can see it as defined in the last video, but this is calculating that. And then I mentioned in the last video, number 5 in bond pricing, that we could use these forward rates to estimate, as of date 0, zero coupon yield curves expected to be in existence at future dates, dates 1, 2, 3, and 4. And here's how that's done. Well, since we are assuming that pure expectations theory is correct, the expected 1 period spot rate at date 1 is just equal to F2, the forward rate over the second period. And of course, you can see here that the expected 1 period spot rate at day 2 is the forward rate over the third period. In fact, the expected 1 period spot rate at date 3 is the forward rate over the fourth period, and the 1 period spot rate expected to be in existence at date 4 is just F5. And that is what we mean when we say the pure expectations theory of interest rate determination is correct and complete, that we can just take these forward rates and assume that they are the 1 period spot rates at, well, this one at date 1, this one at date 2, this one at date 3, and this one at date 4. That's what that means. And now you can go in the cells and you can see that the 2 period spot rate then expected to be in existence at date 1 based upon these zero coupon yield curves, based upon this zero coupon yield curve, these spot rates as they are here at date 0, and then the forward rate that implies, you can see that this 2 period spot rate expected to be in existence at date 1. Remember, the 2 period spot rate in existence right now is 8%, but the one expected to be in existence at date 1, 1 period from now, based upon this information and this very important assumption here, is 10.01%. It's 1 plus the forward rate over the second period times 1 plus D6, which is F3, which is calculated here in this cell. You take the square root of that and subtract 1. Okay? And we can do that because of this assumption. Okay? So same with this. Here we go. The 3-period spot rate expected to be in existence at date 1. And when are we doing our expecting? At date 0. Okay, so at date 0, we're sitting around thinking about, hey, what's the zero coupon yield curve going to look like at date 1 with this assumption and these current spot rates in the zero coupon yield curve in existence right now. And it looks like right now the market expectation is that the 3-period spot rate at date 1 will be 11.02%. Mathematically, that's 1 plus F2 times 1 plus F3 times 1 plus F4, right? So, 1.09009 times 1.11027 times 1.1305538. Take the cube root, subtract 1, and you get 11.02%. Okay? And convince yourself that the 12.02% 4-period spot rate expected to be in existence at date 1, as of date 0, is 1 plus F2 times 1 plus F3 times 1 plus F4 times 1 plus F5. Take the 4th root and subtract 1 and you get this. Okay, and so on here. Let's just do one more here. How about the 2-period spot rate expected to be in existence at date 2? Well, that will be running, if you think about it, at date 2, we'd be going from date 2 to date 3, and from date 3 to date 4. So the forward rates that would be relevant would be F3 and F4. So you can see here that those, that's D6 and D7. So we have 1 plus D6 times 1 plus D7, square root minus 1, and so on. So here is the part of this spreadsheet that allows us to quickly both calculate forward rates based upon the zero coupon yield curve in existence at date 0, and then to use those forward rates to estimate future zero coupon yield curves. Okay, and we see over here that when we make an assumption for a coupon rate on a coupon bond, say $70, coupon rate assumption would be 7% because the maturity value is always 1,000. Then what this thing does is, well, with a 1-period maturity, it assumes it's a zero coupon bond. So if we're pricing off the zero coupon yield curve, the price of the bond would be $934.58 approximately. And not surprisingly, the yield to maturity that exhibits is 7%, same as the spot rate. And then if we assume we have a 7% coupon rate 2-period maturity bond, at a time when these are the zero coupon, when this is the zero coupon yield curve and these are the spot rates, that bond with a $70 coupon payment, paying $70 at date 1 and then $1,070 at date 2, you can see here. These are dates of cash flows assumed across here. So this one now pays at date 170 and 1070 at date 2. So this price of $982.77 is saying that's equal to this 70, right? This 70 right here, discounted back at the 1-period spot rate, since that's a date 1 cash flow, plus the 1070 discounted back using the 2-period spot rate as the discount rate. You can see that in this formula right here. It's L4, which is the present value interest factor, 1 plus C4, right? 1 plus C4, which is the 1-period spot rate, raised to put the power negative L2, which is just -1, so it's just 1 over that, so it's a PVIF. And you can see that, again, that's the L4 value. Multiply that by L3, which is the 70, so it's basically saying it's 70 times its present value interest factor, plus M4 is the next payment, which is the 70 at date 2, times M3, and M3 is what? Well, for a date 2 cash flow, we should be discounting at C5, which is the 2-period spot rate. So this is just using the current value, it's 1.08 to the -2 power, which is the same as 1 over 1.08 squared. So this is just a PVIF, a present value interest factor, associated with this $70 payment. And now there's also a $1,000 principal payment that occurs too. So if you look at this formula here, it's going to be L4 times L3 plus M4 times M3. Then we have to account, I choose to account separately for the maturity value, 1,000 times 1 plus C5. Remember, C5 is the 8% to the minus M2, which is, to the -2 power. So it's just 1 over 1.08 square again. And that's the calculation for the bond. I multiply it here by -1 because of what I'm about to show you. Okay, so don't let that confuse you. I just needed to get a minus sign on the prices because, as you remember from Finance 304, in order to calculate an internal rate of return, we need at least one sign change. And with bonds, they're quite convenient because they have an initial outflow when one buys the bond and then nothing but a bunch of inflows if one holds the bond. And so we have the one sign change, which means, as you again hopefully recall from Finance 304, you'll be able to get a unique internal rate of return. And in the investment world, we call that internal rate of return for a bond the bond's yield to maturity. It's just a plug number. And with this price and these cash flows, in other words, minus 982.77 equals 70 divided by 1 plus y, plus 1070 divided by 1 plus y squared, then that plug number will be 7.97%, 0.0797. And I'm just making an observation that the spot rate is higher than that. And then I draw a chart back here showing that when the zero coupon yield curve is positively sloped, I have the spot rates in this purplish color, and the dark blue color is the yield to maturity. And you'll see that when the zero coupon yield curve is positively sloped, that at each of these dates, except for the first one, of course, that the spot rates are higher than the yield to maturity. Because the yield to maturity is increasing, it's kind of like the yield to maturity value is influenced by lower prior interest rates for some of the cash flows, and hence the spot rates, which are current at the margin, are higher than spots. The spot rates are higher than the yields. And you see that here is, maybe if I stretch this, you'll see it even better. Hold on one second. There you go. You see how they diverge. Okay, so let's look here at well, the same thing applies to the 3-period, the 4-period, and the 5-period maturity. I'm just making different assumptions here as to the length of the life of a coupon bond, and just trying to show you how when you price the bond off the zero coupon yield curve and get these prices here, okay, and then you construct a cash flow stream. I'll put a date 0 in there, that might be helpful. And then here's a date 0, you pay 34.58. It matures at date 1. There's no interest for this one, I assume. No coupon payments. That this is the yield. No surprise there, the yield and the spot rate are the same. But here, because you have a constant $70 coupon payment, a coupon rate of 7%, with a $70 coupon payment, then we see that the price is $982.77, and the IRR of this at date 0, that at date 1, that at date 2 is 0.0797. Jump out here to the, assuming a 5-period maturity coupon bond with a coupon of 7 with a coupon rate of 7%, a coupon of 70. We see that the price would be $862.29. And if this is our cash flow stream, this is date 0, date 1, date 2, date 3, date 4, and date 5, then the yield to maturity, which is the plug number that we could use as a single discount rate applied to all of these cash flows, would be 0.107, 10.7%. And notice that that's less than the spot rate for 5-period of 11%, because these lower spot rates embedded in discounting these cash flows and getting at this price are lower. Okay, and so that's this yield curve spreadsheet that I referred to earlier. Make sure you realize that the analysis here assumes the pure expectations theory of interest rate determination is both correct and complete. And it's not, because in the real world there's liquidity premiums, but it's very important to see how if this pure expectations theory was totally correct, that we could do some neat analysis. And then the next step to account for the liquidity premium is just to recognize the fact that that the forward rates that are shown here are not exactly equal to the future expected spot rates, but they include a liquidity premium. And I'll have a little more to say about that in my next video. Thanks for watching.